Alright, we're going to continue with problem number 5 here. The cable on the suspension bridge is parabolic, so you can see the parabola there goes up this way, and the center right here, and they make this the center is the origin. Find the equation. Well, when the center is the origin, it's a very simple equation. There's no movement for the x and y, but there is always that a value out there. So all we need to solve for is the a value. Well, thankfully we have a point over here, and that's x and y, and we can plug in the y here. We can plug in the x there. And now we have an equation that we can solve. Alright, all we have to do is take the 60 squared, the 60 squared, and divide it by 20. And we have a is equal to 180. So a simple equation is 180 times the y value is equal to x squared. And now they ask, what is the height of the cable at 30 meters? Well, that's the x value, because that's this distance over here, 30 meters this way. So it doesn't go all the way up to 60, or out to 60. So it's somewhere in here. We want to know what that height is. Well, just plug in a 30 right there. We have 180y is equal to the 30 being squared. And 30 being squared divided by 180 gives us 5. And let's just stop and see if that makes sense. 5 meters, could that be the height right there? Well, absolutely, because that height is 20. So that height looks like it could be 5. Alright, identify the conic. Well, 1 and 4, ellipse, they are different. Put it in standard form, x squared minus 6, x plus a perfect square is equal to 4y, factor out the 4, that's a 5y plus, and a 2. Alright, x divided by 2 is 3, square it back is 9, plus 4 divided by 2, whoops, don't need this squared here, is 5/2, and square it back to 25/4. We have fractions that we're working with here, which is fine. Alright, what did I add? I added a 9, so I'm going to put a plus 9, and I added 25/4, but there's 4 of them, so that's really just 25. And that side comes out to be 36. Alright, what do I have here? Well, divide over the 36, x minus 3 squared, divided by 36, plus 36 divided by 4 is just 9 in the denominator. And that's going to equal 1. So there's our equation. And that's an ellipse, of course. Now what can we talk about? Well, we can talk about the center. And that's going to be 3. And that's negative 2.5. And where then it's going to move for the vertices. It's going to move 6, and I only have 5 here, so I'm going to go ahead and scale it and count by 2's. It's going to make the graph a little bit harder to read, but it will fit nicely. So I'm going to go over to 3. There's 2, 3, down 2.5. Well, that's 2.5, it's about right there. We go. All right. So what am I doing for the vertices? Well, I'm going 6 that way and that way. So this is 2, 4, 6, and 2, 4, 6. And if you want to see it mathematically, what I'm doing is I'm leaving this 2.5 there. The y is not changing, but I'm adding on 6 to this to get up to 9, which looks right, and subtracting 6, which is negative 3. So we're just changing this one, up 6, down 6. Alright, where are the co-vertices? Well, for the co-vertices, I'm going to go up and down 3. So let's do this mathematically. I'm going to leave it 3 to the same, but I'm going to go up 3 to 1/2. So that's about right there. And I'm going to go down 3 to negative 5.5. Well, there's 6, so about right there. And that's enough to get a good ellipse out of this. Alright, we talked about one other thing when we did ellipse. We talked about foci. And there's a formula, which is a squared minus b squared is c squared. And a squared is 36 minus 9 is equal to c squared. C squared is 27. Got ahead of myself there. 27. So c is the square root of 27, which is about 5.2, I believe. Let me double check that. Square root 27. Yep, 5.2. Alright, so where are the foci? Well, again, the foci are on this axis, so it's going to be 3 and 3 plus, well, let's write it this way, 3 plus or minus 5.2. It's still going to be at negative 2.5, but it's going to be 5.2 this way and 5.2 that way. So if I add 5.2, I'm up to 8.2. So there's one about right in here. And if I subtract 5.2, I'm going to be at negative 2.2, negative 2.5. So that's about right in there. Alright, so, and the last thing is the eccentricity. Well, that just tells how far this is stretched out. Remember, a circle, a perfect circle, has eccentricity of 0, and a perfect line has eccentricity of 1. So the more you get towards 1, the more stretched out they go. So how far is this stretched out? Well, the c value is 5.2, and the a value is 6. So it's pretty well stretched out, and you can see it's a lot flatter than a circle. So you just take 5.2. Clear. Let's take 5.2 divided by 6, and it's about 0.87 is the eccentricity. Again, the flatter it is, the closer it is towards 1. The more circular it is, the closer it is towards 0. Alright, problem 7. Moving on here. Find the standard form of the ellipse with the given characteristics. Well, the thing you want to do with these is sketch them out. So we have a center at 2, negative 1. So there's a center. So that helps me know that, I mean, this is, I can get all the way to here with my standard form, right? I can get all the way there because I know where the center is. Alright, there's a vertex at 2, 1 half, 2 a half. So at 2 a half, there's a vertex. And that means there's another vertex down here. And what am I doing? I'm going up 1 and a half. So, and I'm on the y-axis, because if this is the center, 2, negative 1, and the vertex is here, this is 3 halves squared. Because that's that distance. That distance on the major axis is 3 halves, and the major axis is on the y. And I went from negative 1 to a half, so that's 1.5 spaces. You can do it mathematically by saying 1/2 minus a negative 1. That's 1 and 1/2. Well, that's 3 halves. Alright, well, in the minor axis is length 2, so it looks like this, 1 and 1, because it's a length of 2, so it's 1 and 1, so 1 squared, and that one's easier. Let's do some simplification over here. 3 halves, if I square that, that's really 9/4. Complex fraction, let's fix it by multiplying by 4. And this is the most simplified version that you can get of this parabola or ellipse. You can leave this as 1, don't write anything there, but make that 9/4. Make this 9/4 4 over 9. Alright, number 8, write the equation of a circle with center. Hey, well, we know the center, so how easy is that? Whoops, plus y plus 3 squared is equal to the radius squared. And that's a circle. Instead of a 1 over here and something being divided, we just go ahead and put the r over there, r squared. Let's see what we have going on here. The center's at 4, negative 3. 1, 2, 3, 4, negative 3 right there. And it's tangent to the x-axis. Well, there's the x-axis. So that means the circle comes up and just touches that. Well, if it just touches it, then that's the radius. And the radius is 1, 2, 3. So I'm going to put my formula, I'm going to put a 3 in for the radius. Probably the simplest way to write this. And we usually just square that term out over there instead of leaving it 3 squared. So when it's a short problem like this and you're not sure what to do, the key is draw a picture. Alright, going on to problem number 9. Identify the conic, put it in standard form, identify the key parts, graph, basics. Subtraction, both squared, well, that's a hyperbola. So it's going to look like, kind of like two parabolas, although they're not shaped perfectly like parabolas. But you have the idea. Alright, let's go ahead and factor this out. So I have 9x squared plus 6x plus something. Minus y squared, and make sure you have a minus 10y right there. That's really the key. Negative times negative puts it back to positive. Negative 47. Alright, let me divide this by 2 and I have 3. Square it, that needed to be a 9. Y squared divided by 2 is 5. Don't need that one there. Square it, and that's 25. So what did I add? I added a 25 and I added an 81 because 9 groups of 9. Oh wait, and this 25 is subtracted because that is a 25 positive. However, it's being subtracted, so it's a minus 25 in there. Negative 47 minus 25 plus 81 is just 9. Subtract this over, it's x plus 3 squared minus y minus 5 squared divided by 9 equals 1. And there we have it in standard form. Where's the center of this? Negative 3 and a 5. Alright, it's going to be best if I scale this by 2s. So I'm going to go ahead and put my negative 10s around there. And center is at negative 3. There's negative 3, 2, 4, 5. And I'm going to build my box around it. On the y-axis, I'm going to go up 3. 1, 2, 3. 1, 2, 3. And to the sides, I'm going to go just 1. So real skinny little box right there. Again, remember your asymptotes go through the corners and through the corners this way. Alright, so what do we talk about when we talk about a hyperbola? Well, again, we talk about the vertices. And this is not negative in the y, so it's not going in the y direction. So this is the y-axis, not going the y, but it is positive in the x. So the vertices are these 2 points right there. So the vertices are at height of 5, but I went over 1. 1 this way, 1 that way. So 1 this way would be negative 2, and 1 the other way would be a negative 4. So there's my vertices. And again, it just kind of, it approaches this and keeps getting closer and closer and closer, closer and closer and closer. It's kind of hard to draw on this one when they're so close. But the idea is that it's going, following the line. It's not like a parabola where a parabola would go out here. It's not going out here, it's going towards the line. So it's kind of like a parabola, but not exactly. Alright, and we talked about the foci. Those points in between here somewhere. And the formula here was back to a squared plus b squared equals c squared. So 1 plus 9 equals c squared. C squared is root, or 10. I'm going to go ahead and solve that. I'm going to add them together and take the square root in one step. So then we just go square root of 10, and it's about 3.2. Alright, so what would the coordinates be? Well, the coordinates of this would be, let me go ahead and write it one way here. I'm going to start at the -3, but I'm going to go plus or minus 3.2. But I'm going to stay at a height of 5. So here's my two foci. Let's see here. -3 plus 3.2 would be 0.25. Let's be just right on the other side of that axis. And -3 minus 3.2 would be at -6.25. And again, it would be 2, 4, 6, and right there. And everything looks symmetrical. Left, right in the middle, same distance that way. Alright, number 10. Complete a table for the curve given by the parametric equations. Alright, well, we've done a lot of parametric equations, and we know that in a parametric equation, the t value influences both the x and the y. So, domain 0 to 4, delta 1. Delta t is 1, so just write it to 4. And what I'm going to do is for the x, I'm going to take it and I'm going to subtract 2. So 0 minus 2 is -2, -1, 0, 1, 2. Now on the y, I'm going to square it, then make it negative. Now this is not like this. That is not what we're doing. We are squaring and then making it negative. So 0 squared is 0, negative is still 0, and 2. 1 squared is 1, made negative is -1, 1. 2 is 4, -4, plus 2, -2. 3 is 9, -9 plus 2, -7. 4 is 16, -16, plus 2, -14. Alright, now if I graph it, now again, remember I'm only graphing, I can get rid of these t values, and I'm only graphing these values here. So, for the x, I only need from -2 to 2. Well, that's going to be easy. Just go ahead and do this little graph here. And for the y, I only need to go up to 2. Well, there's 2. And go down to 14, so let's count by 2s. 2, 4, 6, 8, 10, 12, 14. Try and get them spaced out right. That's -14. That's 2 and 2. I labeled my x-axis, I labeled my y, and let's plot the points. -2, 2 is up here. -1, 1. 0, -2. 1, -7. 2, 4, 6, 7. 2, 14 is here. And again, we have to put the orientation in there. And if you were to eliminate the parameter, you would see it as a parabola. So we want to follow this direction. And between each section, you should show the orientation or the direction it's going. And it's kind of like a rock that's up here, and it's falling down this direction. All right, going on to question number 11. Our job is to eliminate the parameter, write the resulting rectangular equation. All right, so let's see here. Well, what that means is I do substitution, and I substitute one into the other. So I solve one for t, put it in the other. Well, this is going to be the easiest one to solve for t because all I have to do is add 3. So I have that. Now I can put this t in there and there. Let me write that out here. It's going to be y is equal to x plus 3 squared plus 2 times x plus 3. Parameter has been eliminated. I have an equation with just x's and y's, so that's a rectangular equation. But let's put it in standard form. Let's see what I have here. If I square this, if I write it twice and FOIL it, I would have this 2x plus 6. Y is equal to x squared plus 8 x plus 15, starting to look like a parabola, right? Move this over here and I have y minus 15, x squared plus 8x, something to complete this square. What would I need there? Let's see here. This would be x plus 4 squared would be 16, so I need to add 16 to this side. Y plus 1. And hey, that's it. I have my y's on the other side, and there we go. It's a parabola. I can make a real easy sketch of that parabola if I wanted to, right? I have a vertex at negative 4. 1, 2, 3, 4. Positive 1. Whoops, negative 1. And it's facing up. So there's just a quick sketch of what we have. I didn't have to do that, but I wanted to just show you why you are doing what you're doing. Because you can take this and graph it that way. Alright, number 12, plot and label each coordinate. Alright, well, we have a polar coordinate now, and it has 1, 2, 3, 4, 5, 6, 7 rings, so we can say the radius is out to 7 all the way around. And the degrees, well, the theta, well, this is 0, and this is pi over 2, right? And this is pi, and this is 3 pi over 2, and back to 2 pi, and everything in between. So let's see what we need. First one is ring 3 pi over 4. Well, pi over 4 is right here in the middle. That's at 45 degrees angle. And it's at 3. 1, 2, 3. There's position A. Think of it as airplanes. This is a radar tower. Here's the airport. That's the position of the first one. All right. Ring 5, mile 5, 3 root 2. Well, 3 root 2 is straight down here. 1, 2, 3, 4, 5. Point B. All right, well, what about this one? 13 pi over 6. Well, 12 pi over 6, that's this, right? And then I just go one more, so it's this one right here, and 7's out there, so it's 13 pi over 6. 5 pi over 3. Do you remember from the unit circle? This is pi over 3. 2 pi over 3. 3 pi over 3. 4 pi over 3. 5 pi over 3. But watch the distance here. The distance is not 4, but negative 4. So I'm not going towards it, I'm going backwards. 1, 2, 3, 4 right there, and that's D. And the last one is 6, 3. But what is 3? 3, again, that's theta. So this is pi, which is 3.14. So this angle right here is 3.14 for theta. So 3 is probably somewhere in there, I would have to guess. And we're going to 6. Alright, and there's the positions. Think of it as an airport. Here's a control tower. There's 5 planes flying around. These are the positions of them according to that. Alright, going on to problem 13. Convert the polar coordinates to rectangular coordinates. Alright, well, if I had to plot this point on a polar graph, it would look something like this, and I would go out to root, or pi over 6, and that's 30 degrees, so let me just go ahead and draw it. 30 degrees. I'm going to go ahead and put 30 degrees in there, because we all know pi over 6 was 30 degrees, and this is root 3. So there are the coordinates. There's the angle. There's the distance. But what we need now is rectangular coordinates. What is the x? What is the y? X, y. How far over do I go? How far up do I go? Well, hopefully it reminds you of a right triangle. And when you have a right triangle, for this x value, we could write that the cosine of 30 degrees is equal to adjacent over the hypotenuse. And we know the hypotenuse here. The hypotenuse is root 3. Alright, back to our unit circle days. What is the cosine of 30 degrees? Well, that would be the long distance, so that's root 3 over 2. It's equal to x over root 3. Multiply that over there. X would be 3 over 2. And what I've done is I found this. I found this first distance. This first distance is 3/2. This distance is 1.5 right there. Now how far is it up? Well, that's the sine ratio, right? The sine of 30 degrees is the y value over the hypotenuse, which is root 3. What's the sine of 30 degrees? If this was a unit circle, well, that would be 1/2 y over 3. Root 3, multiply that over, root 3 over 2 is equal to y. And there's our points. That's how we get it. We go over 3.5, up root 3 over 2, and we're right there. Polar coordinates, rectangular coordinates. All right, number 14, find the inclination of a line. Well, we already did this once on this assignment. Let's go ahead and see what our line looks like. -3, 10, point up there, 5, 1. So there's our line. So there's our theta that we're looking for. And what did we say the formula was? The tangent of theta is equal to the slope. So the tangent of theta is equal to the slope, but I need to use a slope formula for this one because I don't have a line that's going to give it to me. So 1 minus 10 all over 5 minus -3. Tangent of theta is equal to -9 over 8. Inverse tangent that, let's see what I have here. Inverse tangent, -9 over 8. -48 degrees, that can't be right. Well, what that's telling me is this angle over here. This angle right here is back 43 degrees. Or 48 degrees, that's what it's telling me. So I simply add 180 to it. And theta is about 131.63 degrees. And again, if you needed to change it to radians, you could go ahead and do that to radians. It doesn't say to. Oh, well, it does say it on my paper, so I'm going to do that. 131.63 degrees, 180 degrees is pi radians. And let's see here, times pi divided by 180, 2.2. 974. And let's just see if that makes sense. Well, yeah, because that's 3.14 radians, so 2.9 radians does make sense. All right, 2 questions left. Number 15. A contractor plans to construct a semi-elliptical arch. So he's going to make this arch. It's going to look like that. And it's 20 feet wide, so it's 10 this way and 10 that way. And 7 feet tall. Where should the foci be placed? Well, there's a foci there and there's a foci there. Because then you can use your string to draw the arc. So where are they? How far is it to the left and right? So the answer is blank feet left and right of center. Well, how do we find that? Hopefully you remember that it's a squared minus b squared equals c squared. 10 squared minus 7 squared is equal to c squared. What is that? 10 squared minus 7 squared, 10 squared minus 7 squared, square rooted, square root of 51, square root 51, about 7.14. So he needs to go this far, 7.14, and that far, 7.14, and he'll be able to make the arch. Alright, last question here. The moon travels around the Earth in an elliptical orbit where the Earth is one focus, right here, and the moon's going around as shown. Alright, so they give us a major length, which is this one, and a minor length, this one here, and our job is to find out the greatest distance, which would be apogee, and the least, the perigee, distance from the Earth. Well, let me draw a better picture of it here, just without all the fancy stuff here. Maybe you'll see a little bit clearer. Here's the path, there's the center, and there's the Earth. So what we have to do is find out how far this is and how far this is. Well, let me put some numbers in here. Let me take this, the larger one, 768,800, divide it by 2. And there's that distance there, 384,400. And it's the same thing over here, 384,400. And I'll take the smaller one, 767,640 divided by 2. And this distance up here is 383,820. And this distance down here is also 383,820. And now all I have to do is somehow figure out what this distance is right here. Well, that's that focal distance. Well, thankfully we know the formula, right? It's the same one we did up here. A squared minus B squared equals C squared. A squared is the larger one. Squared minus B squared is the smaller one. So let me go ahead and do that. 384,400 squared plus 383,820 squared, square rooted, take the square root of the answer. I think I have this typed in here wrong. I have to do 384,400 squared minus 383,820 squared. There we go. And now we take the square root of the answer, and that C value is 21,108. So if I want to find this longest distance, the apogee from here to there, it's 384,400 plus this extra 21,000. So why don't I just do that? 384,400 plus an extra 2108, and that is 405,508. And that's that longest distance. That's the furthest the moon is from the Earth. Now what is it over here? The least distance. Well, again, that would be the 384,400 minus that. And that's the closest the moon is. So the moon goes around the Earth, and at the furthest point, at this point here, it's way out to 405, and the closest distance would be this minus that focal is 363. And again, I hope you see it's just an application of our parabolas. All right, I hope this helps you review for the test.